Hello, today we are going to begin Chapter 7. Now in Chapter 7 we will be covering systems of equations and inequalities. We're going to start with the first half of 7.1, which is looking at systems of linear equations and two variables. Hopefully most of today should be a review. So when I have a system of equations, what does it mean to be a solution to that system? So how do we determine if each of these ordered pairs is a solution to the system? Well, what you do is you take the ordered pair and you plug it in to both equations. So in place of x, I plug a 4. In place of y, I plug in a -1. So in the first equation, I get 4 plus 2 times -1 equals 2. Is that true? Well, that gives me 4 plus -2 is 2. And yes, that's true. I plug that same point into the second equation. I get 4 minus 2 times -1 equals 6. Is that true? Well, that gives me 4 plus 2 is 6. And yes, 4 plus 2 is 6. Since, that point works in both equations, that means that, yes, this point is a solution to this system. Now, if we take this point and plug in a -4 for x and a 3 for y, you can see I get -4 plus 2 times 3 equals 2, and that gives me -4 plus 6 equals 2, and that is true. -4 plus 6 is 2. Then I take that same point and plug it into my second equation. That gives me -4 minus 2 times 3 equals 6, which gives me -4 minus 6 equals 6, and that is definitely not true, which means this point is not a solution to this system. Even though it works in one of the equations, it doesn't work in the other one, so it is not a solution. What's happening here, if you think about this graphically, if you plot both of these as these are both lines, if you look at what this actually means to be testing these points graphically, this point 4, -1 is right here, 4, -1. And you can see that that point is the point of intersection between these two lines. It is a point that lies on both of these lines. Whereas this point, -4, 3, you can see is on the red line but not the blue line. Well, that's because it worked in one equation and not the other one. This equation that it worked in, that means that this point is on this line, but because it didn't work in this equation, it is not on that line. So that's what it looks like graphically. So when we're solving systems, we are finding the points of intersection, okay? And those points are called solutions to the system. Hopefully you remember how to solve systems algebraically. Why don't you try this one, since I think you know how to do this already. See if you can use substitution to solve this system. You can press pause in this video, do that, and then press play when you're ready to check. All right, let's take a look at what you did. Hopefully you did something like this. I solved the second equation for y. Really, you could solve for any one of these four: y in this equation, x in this equation, x in this equation, or y in this equation. The other three choices, though, would have you deal with fractions along the way. So that's why I think it's easiest to solve for y in this second equation. And then you plug that into the other equation in place of y. Then to solve this, you distribute the 2. You simplify your equation. You then divide by -1, you get x is -2. That, of course, is not your final answer. You need to then take that -2 and plug it into either one of your two original equations. Solve for y, and you get y is 5. And you can write your answer either way. Usually we write it as an ordered pair with x first and y second. So our solution here is -2, 5. And that method is called substitution. Next, let's look at an example of using elimination, is probably what you've called it before. It is also called addition some places. So those mean the same thing. So again, I hope you remember how to do this. Why don't you give this one a try? Press pause on this video and then press play when you're ready to check. All right, let's take a look at what you did. You've got a few options here. First thing I would do is get everything, all my x's and y's over to one side and line up my x's first and my y's second in both equations. Then you've got some options here. You could either try to make y's the opposite, so you can eliminate y's, or you can try to make x's have opposite coefficients and eliminate x's. I chose to eliminate y's by multiplying this first equation by 4 and this second equation by 3. When you multiply this equation by 4, make sure you're multiplying everything on both sides. So 2x times 4 minus 3y gets multiplied by 4, and then on the other side of the equal sign, that 9 also gets multiplied by 4. I think that's one of those common mistakes I see is people forget to multiply the number on the other side by that number. But you can see by multiplying this first one by 4 and the second one by 3, I was able to make these y's in these two equations have opposite coefficients. And now here's why this step is sometimes called addition, is because the next step is to add these equations to each other. So I add the left side with the left side, and I add the right side with the right side. And I can combine like terms here. 8x plus 9x is 17x. Negative 12y plus 12y is 0y. That's why there are no more y's on the left side. And then 36 plus 24 is 60. And then I continue solving by dividing both sides by 17. 60/17 is my answer for x. Oh my gosh, how fun are fractions? This is so exciting. Then what I do is I take that answer and I plug it into either of my two original equations to find y. So I plug in that answer there. I multiply it by -3, and then I do 8 minus that, or you can type all that into your calculator at once, press enter, and you get -44 over 17. Divide both sides by 4, and again, you can use your calculator for that, and you get -11/17, and there's how I'm writing my answer as an ordered pair with x first and y second. Next, let's take a look at a few special cases. So for a problem like this, it says solve by any method, so you could use substitution or elimination. What I'm going to do here is I'm going to use elimination. So you can see I decided to multiply that top equation by 2 so that I could make these x's have opposite coefficients. So I double everything in this equation and I get 10x minus 4y equals 8. I then leave this second equation alone. I then add these equations together and you can see eliminate x's. 10x plus negative 10x is 0x. But then you also notice something weird happens here. Negative 4y plus 4y is 0, which means I accidentally eliminated both variables without really trying to. But since I'm adding these equations together, I still have to add on the left, and I get 8 plus 7 equals 15. Now, there's still a number over here on the left side. It's not like everything vanished. I got 0, okay? And 0 is still a number, but now I have something that says 0 equals 15. Well, wait a second. No, it doesn't. 0 does not equal 15. That's false. So what in the world does that mean for my solution? Does that mean my solution is like 0, 0? Well, no, that would be if, I got x equals 0, and that's not what I got. What this means, since I got a statement that's false, that means that there are no solutions. And if you think about what that means graphically, these two would be parallel lines that don't intersect anywhere. So if you get something like this that is false, that means there are no solutions. Let's take a look at another special case. Here's another one where it says solve by any method. You can see this one already has x equals, and then everything over on the other side. So I'm going to use substitution for this one. Normally I prefer elimination, but if there's one set up like this, you should definitely use substitution, I think, because it's already ready to go for a substitution. Just plug that in right there. So I'm going to do that. I plug in the 4y minus 8 in place of x, like so. I then distribute the 5, like so. I then combine like terms. 20y minus 20y is 0, so I get -40 equals -40. Well, wait a second. All my variables went away accidentally. But now here is actually a statement that is true. -40 does equal -40. -40 is the same as -40, which, yes, that's true. So what does that mean? Does that mean my answer is all real numbers? Now, if my answer were all real numbers, that would mean that like everything is a solution. And that is not the case. And here's maybe graphically why. These two equations are equations for lines that are actually the same line. So the first equation makes this red line, the second equation makes the green line. They are actually the exact same line, which means where do these lines intersect? Well, at every single point on the line they intersect. However, there are points that are not on either line. All these points are not solutions to this system of equation. So it's not that every point is a solution. Okay, there are many points that are not solutions. So how do we talk about the solutions? Well, how many are there? Well, there are still infinity because there are infinity points on these two lines. So the way you would word your answer is you say there are infinitely many solutions. Okay. Another way to write that would be like this. This is using set notation. It's the set of all ordered pairs x comma y given that, and then this is just one of the equation for this line. So given that x is equal to 4y minus 8 would be how we define all the points that are solutions. So that's it for our lesson today. Give that homework a try, and please let me know if you have any questions.